So this is the continuation of the previous recording, and here we are going to demonstrate the CP properties which our software can handle. So what we have done is we have designed a configuration properties file where we can mention that the database that we have designed, whether we want it to be a AP kind of a database or a CP kind of a database. So initially when we were testing and we were demonstrating AP database, we have put AP here and have demonstrated the AP properties of the database. Now we're going to change it to CP and start our database server so that when network partition occur, then instead of the AP properties, the CP properties will be exhibited. So right now the database is in partition mode. Since the nodes are not able to talk to each other through port 8080, we have removed this. So we have to put this rule back. Because of this rule and this rule, inbound and outbound rules on 8080, the nodes are able to talk to each other and send heartbeat to each other. That is one mechanism to ensure the whole database is not partitioned. But when we turn off this rule, then the heartbeat exchanges do not happen and the nodes determine that the whole database system is partitioned. And then they start behaving either in an AP manner or in a CP manner, depending on what is configured in this config file. So, in a nutshell, the database that we have designed is configurable to be AP or CP. We need not change any code to change the behavior of the database system. Now that we have changed the config properties of the database, let's start the databases. So this database servers, this one is master, this one is slave, whose IP is this one, and this was another slave whose IP is this one, right? Now since the network is not partitioned right now, we can use the ELB to create and read a record. We again use the curl command to send a post HTTP request to the ELB, which is then forwarded to any of these three nodes. And this request consists of a record, key value pair, key is shape, and value is round. We just shoot this request and unfortunately we do not see the request coming through any of these three nodes. The reason could be the instances are just now started, so it is not associated with the ELB yet. So for the ELB, they are still out of service. We have to wait for a while for these three instances to come back up and become in service, and then we can start using and the ELB and forwarding requests to the ELB. Let's wait for a while. In the meanwhile, we will just have a look at the CP properties that we are going to demonstrate. For a master-slave architecture, this is a summary of the CP properties. For the read mechanism, if a read requests come to the slave B or C, they won't be allowed. But if it comes to the master, it will be allowed. On the other hand, for the write requests, if the request comes to the slave, on a similar fashion, it won't be allowed. But if the write requests come to the master, it would be allowed. So what it means is pretty much the slave nodes are unused in a CP mode. In order to maintain a consistency between the read and write requests, on the get and write will be allowed only on the master. This will ensure that every time you read, you get the same data. And when you write, only one version of the data is stored across the whole database. We're going to demonstrate these properties through a database design. And in the meanwhile, what we could see is that these three instances are back in service. Now we can start using them. We try the same request once again. We try to, now the network is non-partitioned. They're all connected to each other. So we just send a post request to the ELB. The request is given to the master. Master replicated, master has written to its own database, and after that replicated it to the slaves. So let's do a get and see if the whole database is in sync, like the master and slave all contain the same data or not. There was something that I have done. I don't know what I did exactly. Let me try this once again. Let's try the get. I pressed something, I don't know. So some manual mistake. So let me try the get once again. So I tried the get. So we are trying a get on a wrong record. We're trying a get on color. But just now we created the record on shape. So let's change the record. Let's change the key rather. Make it shape. Right. Okay, the request went to the master first, so we got a response from the master. We get the shape is round. That's what we have written that time. Let's try the get once again. We get response from the first slave and says shape is still round, version 1. Right. We try the get once again. We get response from slave 2. We get the same data. So because these three nodes are interconnected to each other right now, the replication could happen and all of them are having the same data. However, now we will start simulating the network partition by blocking the 8080 port between them. At that point, that replication would not be able to happen because they're not connected. In that case, in order to maintain consistency across the whole database system, no read or write will be allowed in the slaves. Read write will be allowed only in the master. We have to confirm that. So let's first partition the whole database system. In order to partition the whole database system, we do a simple mechanism. We just block the 8080 port, which is used to exchange heartbeat among the nodes. Instead of removing the whole rule as such, we just make the port as 0. So this becomes essentially a void rule, right? So right now we have blocked port 80 and these three nodes are not able to talk to each other. So the first thing that we will try is we already have a shape record in all the three instances of the or all the three nodes of the database system. We will try to update the record in master. Shape was round before, right? We try to make the shape as square now, and we uh, okay. But before that, we have to get into the jump box in order to try this. Because the network is partitioned, if we try to use ELP, we don't know where exactly the request is going to land. So in order to effectively understand the behavior of each kind of node, master or slave, let's get into the jump box and from there direct the requests to the specific nodes. So we are into the jump box right now. So from there, I'm gonna send a put request, update request to the master on the existing record, that is shape is round. We're gonna make shape is square. Let's see if master allows that or not. So master receives the put request. It says yes, updated record, new record is shape is square. It tried to forward the same put request to the slaves, but unfortunately they are not alive or they are not able to, they are not reachable. So master is not able to replicate the data. So what does it mean? It means that the slaves right now must be having a stale data and the master must be having a fresh data. Let's verify. Let's try to do a get on this record from the master first. Master says version 2 and the shape has become square. It was round before. What is a record in first slave? First slave says, I don't know, I cannot even allow you get. I might be having a stale data, that's fine, but this is a CP mode and I cannot allow. So this is the basic principle of CP mode, that when a get request is received in a slave, it won't be allowed. To the contrary of the AP mode, where a get request will be allowed. Let's try the get request to the other slave. It says the same thing, network is partitioned and I'm in CP mode, so the get request won't be handled. So this is the first point, that whenever a write request is forwarded to the master, it will be allowed and it will not be replicated to the slaves. Second point, a get request or the read request will be allowed from the master but will not be allowed from the slave. Let's go to the next point. Let's try to update the record, shape record, which is already present in the slaves, because before partition we created this record. So let's try to update it. Will it allow or not? Let's check. So it says, yes, I have received a put request from the external request. I'm trying to put it to master, but unfortunately I cannot reach the master, and also I am on CP mode, so I cannot handle the put at all. So this put or the write request that is forwarded to that is sent to the slave is not handled. To confirm that, we need to see that shape is still round or it has changed to oval. Let's check. So there is the point. It's CP. So we cannot even check that what is there in the record, because if it allows the get request, then the data that we are going to get right now will be stale, which essentially means that the data given by or read by, from the master and the data read from the slave will not be same, hence inconsistent. So in order to maintain CP, we have to make sure that even get request is not allowed in master and slave. Sorry, in slave. Get request won't be allowed in slave. Okay. We can check the other things also. For example, we did check put is not allowed in slave but allowed in master. We can check if delete is not allowed in slave or not. Yeah, delete is not allowed in slave. Let's just verify if it got deleted or not. Again, I cannot verify because get is not allowed in slave. However, did that delete trigger any deletion in master? Let's check in master. No, master still have the data. So basically the delete that what was requested to the slave was not entertained. But if the delete is sent to the master, it will be entertained. See, delete request received and record is deleted. So if we try to see if the data is still there or not, there is no such data. So this means delete request sent to the slave is not entertained, because we are in CP mode and the network is partitioned, and the delete request is entertained by the master. Same way, a post request if sent to the master will be handled. See, the post request body is this, new record is this. Just to verify if the post request actually created a record in the master or not, we use a get and we see yes, the record is created. However, is this being replicated to the slaves or not? No, it should not, but we need to verify. Let's see if the record, this new record exists in the slaves or not. It's in a CP mode and partitioned, so the get won't be allowed. What if we try to send a post to the slave? It should be outright rejected. Let's just confirm. Master is not reachable, post not forwarded, CP mode enabled. So this is pretty much it about the CP properties of the given database software and its implementation. The database that we have designed, uh, we have extended it and provided a configuration property through a properties class where we have a config file. There we can mention what kind of mode, AP or CP, we want the database system to behave like when a network partition happens. And once we make the changes in the config properties, we start the database system. Then subsequently, when the network partition happens, the database system behaves accordingly. Here in this whole demonstration, we have seen that we have started this database in CP mode. So when there was no partition, it was acting as a normal master-slave replication. But when partition happened, as per CP properties, read and write was only allowed by the master. It was not allowed in the slave. Thank you for the demonstration. Thank you.